Hi everyone, welcome back to the Centre for Computing History and part 2 of our Beginner's Guide to Programming. Hope you've enjoyed it so far. We're going to be using the BBC Micro from 1981 to demonstrate some of the fundamentals of programming. And on the screen right now is where you can download emulators, as well as an additional online version of the BBC Micro that you don't even need to download. You can just go to the web page and start using the online BBC Micro there, even with a surround that looks like the cub monitor that we have here. Now in part 1 we looked at variables and loops, and in part 2 we're going to extend our knowledge of loops and use conditional statements like if, then and else to do different things depending on the value of a variable. So from part 1 you might remember our counting program. Let's just quickly type that in again. 10, a equals 1, 20, print a, 30, a equals a plus 1, so increment a by 1 each time, 40, go to 20. And when we run our program, it just continually counts. So this is known as an infinite loop. There's no way for the computer to get out of this except for us to interrupt it or turn the power off. So let's press escape and interrupt our program, and let's list it on the screen. Now there's another type of loop we can use. This is called a for next loop. So let's leave our program on the screen here, but we're going to type new. That clears the memory, so it's still on the screen but it's not in the computer's memory anymore. And let's type in another program. 10 for a equals 1 to 100. Okay, so this is a bit different. So for a is 1 to 100. So this is saying set a as number 1 on the first iteration of the loop and then increment it by 1 each time. Now by default it always increments by 1 each time, but we could put another statement on the end saying step, and we could increment by 2 or 4 or whatever. Line number 20, print a. Line number 30, next a. So this is our for next loop. It does everything between the for and the next. So a starts at 1 and it prints a, so it prints 1, then it says next a, so it goes back to the for loop stating what a is, and this time it's 2 because it's automatically incremented by 1 and it keeps going round. So if we run our program now, rather than continually running, it's going to do this. So our program runs, counts all the way up to 100 and stops. And if you look at it, our program's 1 line shorter now. So this is a nicer way to create a loop in our code. It's more efficient because it used 1 less line of code, and it's much more controllable. It says to count from this number to that number. We could change it. We can type in line number 10 again for a equals 23 to 32. Okay? So now a, on its first iteration of the loop, goes from 23, on the next iteration it's 24, all the way up to 32. So when we run it, it just does that. So a very much more controlled way of looping through our lines of code. As I said, we can use the step statement. So we can type in 10 for a equals 1 to 10 step 2. So when we run it, now it jumps. So a is 1, so it prints that, and it adds 2, so it becomes 3, adds another 2 to become 5, 2 to become 7, and another 2 to become 9. So it never actually printed 10, where we told it to stop, because it got to 9 and it added 2 to the loop. So it actually became 11. So as soon as it's higher than that number at the end of our for next loop, it stops. And it goes on to run the rest of the program. So quite often in a program, you want to count from a specific number to a specific number. And this is a great way to do that with the for next loop. But again, let's go back to our original program. So let's reset the computer. Let's type in a equals 1. This is our original counting program. Print a, 30, a equals a plus 1, 40, go to 20. Run our program again, and we know this is an infinite loop, so it will just keep doing this. Okay, let's introduce the ideas of if, then, and else. Let's start with if and then. So we have a variable here, which is a. It prints it, it adds 1 to it, and it goes around and prints it again. we're going to put another line of code in between line number 30 and line number 40 to test the state of A. So let's have a look. Line number 35. Okay, so line number 35, because it's between line number 30 and 40. And we're going to say, if A equals 100, then end. Okay, now the end statement just means stop. End the program. Finish there. Let's look at our program. So set the variable A to be 1, print it, add 1 to it. If A is 100, then stop immediately, end. Otherwise, it goes on to the next line and it goes back to line number 20 and prints A again. Now, what do you think this is going to do? You'd be forgiven to think that this is going to print the numbers 1 through to 100. But let's see what it actually does. So it starts at 1, but it only goes to 99. Let's have a look at our code and work out why. So we've set the variable to 1. We print it, so it prints 1, adds 1 to it, and then checks to see if it's 100. Well, it isn't, it's 2. It's just added 1. So it's 2, so it goes back round and prints it again. And it keeps doing that. Let's look at the status when it gets to 99. So A is 99 and it prints it. So it prints 99 on the screen. It adds 1 to it, so it becomes 100. Is A 100? Yes, it is. So it ends. But it hasn't printed it yet. It hasn't gone round and printed that number yet. So this is an interesting thing that trips a lot of people up. Even experienced programmers come up with this kind of problem quite regularly. So this is kind of a logical problem. Just looking at the logic of the code and what happens and when is really important in programming. So our program is not printing 100 because it tests A before it's printed it. Hope that makes sense. Think about it, look at the code, think about what it does in your head and how the program works. You can see that we add 1 to it, we see that it's 100, and we end the program. There's 2 things we can do here to make this program do a little bit more what we expected it to do. The first one, we could change if A equals 101, then end. So it's now testing to see if A is going to be 101. So if we list our program again, we've run the loop one more time because it's now checking to see if it's 101. So it lets it do the 100 loop, checks it to see if it's 101, and then ends. Let's run our program. So it started at 1, it gets through, and gets to 100 and still prints it. Good stuff. But there's also another way. I don't know if you can guess what that might be. But it doesn't mean changing the variable when we check it, and it's a slightly more efficient way to do it. It's really simply about where we check the variable. So let's get rid of our line number 35 again. And if we list it, we're back to our original program. Rather than testing the variable at line number 35 after it's incremented A, let's check it before it increments A. So line number 25. So we can put our original line back in. If A equals 100, then end. So it's a very, very subtle change, but it's simply about where we test the variable. So this time now we print A and then we check to see if it's 100, then we increment it by 1. So what we've done is just check it before it does the increment. Now we run it, starts at 1 and it goes through to 100. So where you test your variable is quite important. And even experienced programmers get caught up in this from time to time. Now the if statement isn't only for numbers, we can use it on string variables as well. Let's type in a program that we've done before in part 1. Let's clear the screen. Let's put print, enter your name. Let's put a space after that. And a semicolon to say put what we're going to type in on the end of that line. 30 input name $. So you remember from part 1, we're going to store whatever they type in into this variable name $. And then we're going to use our if then else statement to do something depending on what we've typed in. So we're going to say 40 if name $ equals Jason. So if it's my name I type in, then print wow, you're my programmer. Okay. Else, print hello, space, and then semicolon, name, dollar. So this is quite a long line. So if name string is JSON, so specifically if what they type in is the word JSON, then print, wow, you're my programmer. Otherwise, this is where the else comes into it, else print hello, name dollar. And this is what we did in our original program where you just print whatever they typed in to the name dollar variable. So let's run our program. So maybe the person that comes up to the machine is Bob. Hello, Bob. Okay, so we type in Bob and it just says, hello, Bob, back to that person again. Let's run it again. Maybe it's Doris this time. Hello, Doris. So you can see it's just repeating back what that person typed in. Even to the extent of if we just type in random characters, it will say hello and then our random characters. So it doesn't know what we're typing in, but it's just repeating it back to us. And then now we're going to type in JSON. Okay. Wow, you're my programmer. So it's done something different depending on what we typed in. Very specifically, if it detects those exact characters there, JASON, and they match, it does what we told it to do. It displays on the screen, you're my programmer. So we can use the if and the then and the else statement to do something if the conditions are right, i.e. name string is JSON in this case, or do something else if it isn't. Now that's a very, very powerful command. The if and then else commands allow the computer basically to make decisions. And that's really important because lots of programs are about making decisions on what variables are to do something accordingly. There's our program just to go back over it. So we clear the screen, type in, enter your name, we store what they type in into the name dollar, we test name dollar to see if it's JSON, and then print, wow, you're my programmer. Otherwise, this is where the else statement comes in, print hello, and then whatever that name is. So this could be a backdoor into your program. If you ask somebody at the beginning of the game what your name is, then maybe it will use that name within your game. But if you type in a special code that only you know, maybe it could unlock something in the game, extra lives or a backdoor or something like that into the game. So we can use the if then else statement to check numbers to see if a variable has a certain number in it or if it's greater or less than a certain thing. And we can use it to test variables to see if that variable matches what you want it to match. There's also other ways of doing things. So if they type in a whole sentence, you can look for a specific word in that sentence using something called a substring. Now we're not going to go into that today because it gets a bit more complicated. Maybe that will do that in a later part of this. But this is the basic way that we get computers to start making decisions based on variables. So at the museum we have a programming guide that's out with our machines all the time. We've gone through most of the steps in that guide and then we get to a little game, and that's what we're going to do now. So we're going to type in a few lines of code that creates a little game using the statements and the ideas that we've already used. So let's reset our computer and start typing in our game. So 10, CLS, we know that one, clear screen. So that clears the screen. 20, num equals RND 100. Okay, so we create a variable called num, short for number. And in that, we store a random number between 1 and 100, decided by the computer. It chooses the random number for us. Now then, line number 30, print, I am thinking of a number. And 32, so we don't have to always go up in tens. We can use any numbers between those as well. Print between 1 and 100. Okay, so I'm thinking of a number between 1 and 100. This prints it on two separate lines. 34, print. Now a print statement on its own just means leave a space on the screen. Where are we? 35. Print. What number am I thinking? Oh, spell it right. Thinking of question mark. And it's gone off on the ends of the line there. That's okay though. And then line number 40, input, guess. Now similar to our last program where we put input name dollar, this is now input guess. So we're going to store what they type in into the guess variable. Now it hasn't got a dollar on the end because we're expecting people to type in a number. So we store it in a variable called guess. Don't need the dollar sign because we're not typing words into it. 50. Now then, let's use our if and then statements. If guess is greater than num, okay, so this symbol here means greater than. The way I remember this is this side of it is bigger than that side of it, which goes down to a little dot. So this is greater than number. That's how I remember it. So if our guess that we've typed in is greater than the number, then print lower. Oop. Okay, so our guess is higher than the number it's thinking, so it gives us a clue and says lower than that. 60. If guess is less than, remember, so this side here is smaller than this side here. That's little dot, goes out bigger. So that's a less than. Our num variable then print higher. Okay, does that make sense? So these characters here allow us to test whether our number is less than or greater than another number. And as we've used before, if guess is equal to the number, to num, then print you guessed it, exclamation mark. Else, go to 40. Okay, so a bit longer, and it's gone on to the next line. But if the guess is the same as the number, i.e. it's equal to the number, then print you guessed it, so it displays that on the screen. Otherwise, and this is where the else statement comes in, else, go to 40. So if it's not the same, go back round to line 40 and ask them to enter again. And then 80, it's just a line of code that says end the program. Okay, so if you've guessed it, it prints, you've guessed it on the screen, and it ends the program. Let's try it. So, clears the screen, displays, I am thinking of a number between 1 and 100. What number am I thinking of? So one way would just be to put in random numbers and guess like that. But that's not a very efficient way of doing it. The most efficient way of playing this game is to actually halve the number each time. So we're thinking of between 1 and 100. So what's halfway between 1 and 100? Let's guess number 50. Okay? So we type in 50 and it says it's higher than that. So we now know the number is between 50 and 100. So we've just got rid of half of those numbers. We don't have to worry about them now. So our field of play now is only 50 numbers. So let's go halfway between 50 and 100. So let's type in 75. So now we know it's higher than 50, but lower than 75. So now we're only dealing with 25 possibilities. So let's go somewhere roughly in the middle. Let's say 66. Higher than 66. So higher than 66, but less than 75. Let's try 70. Higher than 70, but less than 75. Only 5 now. Let's try 72. 72, guessed it. So the program is working really well. Okay, so it's gone through and it's compared the numbers we've typed in with the number that it was thinking of. And because it's a random number, we thought of at the beginning, if we list our code, so it chooses the random number. If we run the program again, do we think it's going to be 72 again? Should we just try it straight off? 72, no. So it's thought of a different number this time because we used that random statement at the beginning. So it's lower than 72. So there's our game. Quite good fun, but there's ways that we can make this even better. So if we look at our code, we could take some of the ideas that we learned in part 1 and introduce them into our new game. So we could maybe make it make a sound each time you type in a number. Maybe we can make it a high-pitched sound, or maybe a rising set of notes when we win. Maybe when we win, rather than displaying, you guessed it, it could jump into the screen that puts all the lines on and in the middle writes, well done, you guessed it, or something like that. So we can introduce sound and graphics into our game. Perhaps you could make the game more interesting by counting the number of times you guess. And then the idea of the game is to guess in as fewer times as possible. So we could introduce another variable to count those number of times they guessed and display that on the screen. Or maybe we could limit the number of times they have to guess. So they just can't keep guessing, they have to do it within, say, 10 tries or whatever. Or maybe we could make it guess a number between 1 and 1,000. But if we did that and you played the game by halving it each time, does that make it any harder? Have a think. So now you've got all the tools that you need to make this game a bit more interesting. You can introduce some sound into it, do some graphics, make it your own. Make it say different things when you get the numbers wrong or when you win. Maybe get it to ask your name at the beginning of the program, so when you win, it congratulates you with your name, saying, well done, Jason, thanks for playing, or something like that. In part 3, we're going to introduce some simple graphics and create a chasing game. Until then, enjoy programming, and we'll see you next time.